today we're going to move on to look at similar area. So far we've looked at similar lengths and now we're going to look at similar area. So first example, these two rectangles below are both similar. Find the area of the larger rectangle. So we're going to use our previous skills of calculating the scale factor to start with. So this smaller rectangle is going to be our old shape and it's been enlarged to become this bigger rectangle, making this our new shape. So we're going to find out our scale factor, and I'm going to call this our linear scale factor. So 15 over 5, which is our new over old, and then 15 divided by 5 is 3. So our linear scale factor is 3. So we can use that to find lengths. But because we're trying to calculate the area, we're going to introduce something called the area scale factor. And to work out the area scale factor, you're going to take your linear scale factor and you're simply going to square it. So 3 squared equals 9. And now we're going to use our area scale factor to enlarge this area of 10 by multiplying. So the area of the larger rectangle is 10, which is a smaller area, times by our area scale factor, which equals 90 squared centimetres. So be careful of your units here. We are dealing with area, so you need to make sure you've got your squared units there, so squared centimetres for that one. Can you please copy this example down? And for this, you do need all 3 lines of working to get full marks for these types of questions. If you need to pause the video any time to copy them down, that's absolutely fine. Okay, on to example 2. So below, these triangles are both similar. We need to calculate the area of the smaller triangle. So we're going to be looking at a reduction this time. So this larger area has been reduced and we're trying to work out what this smaller area is. So to start off with, as always, we're going to find our linear scale factor. And to do that, we're going to take our new over old, and we're comparing the lengths because that's a linear scale factor. So new over old, so 4 over 8, and we can simplify that down to a half, and we are dealing with a reduction. And once we've found our linear scale factor, we then need to calculate our area scale factor. And to do that, we're going to take our linear scale factor and square it. And notice these large brackets, that means that entire half is all being squared. And then to work that out, when you're squaring a fraction, you square the top and you square the bottom. So 1 squared is just 1, and then 2 squared is 4. So we've got our area scale factor of 1/4. And now to work out the area of that smaller triangle, we are going to take our larger area of 20 and times it by our new area scale factor. So 20 times 1/4 is 5 squared centimetres. Again, be careful with your units. So these previous 2 questions you should manage absolutely fine without a calculator, but some questions you may require a calculator, which is absolutely fine. So on to a third example. So the ellipses below are both similar. Find the area of the larger ellipsis. So we're back to looking at an enlargement this time. So first step, as always, we need to calculate the linear scale factor. So our linear scale factor in this case is our new, which is our larger one, because that's what we're trying to find the area of. So this is our new shape divided by our old shape, so 30 over 12. And we can simplify that by dividing top and bottom both by 6 to get 5 over 2. Once we've found our linear scale factor, we are going to calculate our area scale factor. And to find that, we're going to square our linear scale factor. So all of that squared, which means we're going to square the top. 5 times 5 is 25, and square the bottom. 2 times 2 is 4. So now we've got our area scale factor. We can go ahead and calculate the area of that larger ellipsis. Okay, so the area of the larger ellipse is, the area of the smaller one is 36. So we're going to take that 36 and we're going to multiply it by our area scale factor. Always make sure that you are using the area scale factor when calculating the area and you're not going back to the original one. So you can either work that out yourself or pop it into a calculator and you'll get 225 squared centimetres. Again, those 3 examples, please make sure you've got them all copied down to refer back to as well. Okay, the next slide is one for you to try. So below, the parallelograms below are both similar. Can you please find the area of the smaller parallelogram? So first step, calculate your linear scale factor by comparing your 2 lengths. Find your area square factor by squaring it, and then you can calculate the area of the smaller parallelogram. So pause the video here, when you unpause, we'll go over the answers. Okay, let's see what we have. So first step was to calculate the linear scale factor. This smaller shape is our new, so we're going to take new over old. So linear scale factor is 12 divided by 18. We can simplify that by dividing top and bottom by 6 to get 2 over 3. Second step is to square our linear scale factor to find our area scale factor. So all of that squared. So 2 squared gives you 4. And then 3 squared gives you 9. And then we've got our area scale factor. We can now use that to calculate that reduction. Okay, so the area of the smaller parallelogram is 450 multiplied by our area scale factor to give us 200 squared centimetres. And that is your final answer. So well done if you got that.